In this video, let's talk about irrational numbers. So let me start with a quick story to give you more context. Hippasus was the one who discovered irrational numbers and he paid heavy price for it. No one ever knew what happened to him. But he and his fellow friends were the one who followed Pythagorean philosophy. And they believed that anything happening in this world, any phenomena that is happening in the world, is the result of numbers. So anything in this world can be expressed as the ratio of two numbers. Ratio of two numbers. That's why rational numbers came into picture. That's why everyone till that time believed that whatever number we are talking about, we can always represent that as a ratio of two integers. And that's why such numbers were called rational numbers. Rational numbers that we have studied in our previous videos, that any number that can be expressed in the form of p upon q, where p and q are integers and q is not equal to 0, are rational numbers. So basically all the numbers that people studied, may be whole numbers, natural numbers, fractions, or integers, negative numbers, positive numbers, anything that came under the category of rational numbers. But there was a small incident which started causing problems for everyone. And what was that? So that was a simple figure that led to all the problems. Let's say that I have a square with equal sides of 1 unit each. This is 1, this is 1. If I would ask you, what would be the length of this diagonal? So if you might have studied Pythagoras Theorem, you will be studying this later on, but as per Pythagorean Theorem, let's say this side is x, then x square would be equal to sum of the squares of this right angled triangle. That is 1 square plus 1 square, this side square plus this side square. This is what Pythagorean theorem says. And don't worry if you don't know this. I'm just telling you here to give you more context about irrational numbers. We will anyway learn this in our later chapters. So this would mean that x square is equal to 1 square is 1 and again 1 square is 1. So x square is 2, which means x came equal to square root of 2. Now this was the problem. This number, as per Hipparchus, he was not able to express this number in terms of ratio of two integers. He tried really hard, but he was not able to. So then what he thought, let me prove that this is not a rational number, and thus he used the proof of contradiction, which we will again learn in coming videos. But let us assume at this stage that he was not able to prove that this square root of 2 cannot be expressed as the ratio of two integers. And hence, he started a new category of numbers called irrational numbers. So all these square root of numbers which are not perfect squares, for example, square root of 3, square root of 5, square root of 7, all these came under the category of irrational numbers because it was not at all possible to express such numbers in terms of p by q. So that's what this definition started with. That's how we started with irrational numbers. The irrational numbers are all the real numbers which are not rational numbers. Very simple definition. Any number that cannot be expressed as rational numbers are irrational. You can construct rational numbers in terms of ratio of two integers, like it's said here, but you can never express irrational number in terms of ratios of two integers. Another popular example of irrational number is the number pi. So pi, generally people say that it is equal to 22 by 7, but pi is never equal to 22 by 7. We approximate the value of pi as 22 by 7. Pi is actually the ratio of the circumference to the diameter of any circle, and this is irrational number because we cannot express this number in terms of ratio of two integers. And just to let you know more, and we would study this in detail in the coming set of videos, the decimal representation of irrational numbers. The decimal representation of irrational numbers follow a very specific characteristic, as you can see here. These numbers keep on going, they never end. The decimal representation of irrational numbers would never end. You cannot end it at a specific point. This would go on and on and on. First thing, and secondly, it will never repeat itself. You cannot see a pattern. So this is another way to actually identify irrational numbers. If you see any decimal representation such that they never terminate, and they don't have any pattern, follow no pattern, then such numbers would be irrational. For example, pi. Similarly, square root of 2. If we would convert this into its decimal representation, and we can talk in later videos how we can do that, the decimal representation of square root 2 will never end. These digits would never end, and also you will never ever get a specific pattern. And this is true for all irrational numbers. So I think this is more than enough information in one video, but I hope you have a clear picture of what irrational numbers are, and I think I was able to do justice to give you a good context about irrational numbers.